Okay, here's some help with homework sheet number 8. So, question number 1, we've got two functions, f of x and g of x, and the question is asking us to rewrite those as f of g of x. So that means we put the g formula into the f formula. Now when I put the g formula into the f formula there, then that's going to give me, take away that x and put that in its place, it's going to give me an x squared plus 2, then I've got to square it, okay, because of this square here, and then take away 1. Okay, if I remove all the brackets there and tidy up, I'll get my answer. Before I do question 2, forgot there's another part of question 1. Once you get this answer, you've got to factorise it. Okay, now when you're going to factorise it, I would like you to think about 4a squared, 4a squared plus 4a minus, plus 3. Right, so think about 4a squared plus 4a plus 3. Think how you would factorise that into two brackets. And then once you've thought about factorising that into two brackets, then think to yourself, how could I factorise this into a similar two brackets? -1. Oops. Question 2. We've got P, Q and R. So the first question is we've got to do P minus Q plus 2R, I think. Not got my sheet with me. Okay, so turn each of these vectors into components. So 1, 1, minus 1. This one would be 1, there are no j's and 4 k's. And this one would be 4 minus 3 and there's no k's. And then you do this vector, subtract this vector, add on two of these vectors, which was 1, 1, which was the second part of the question, P dot R. Well, write down what vector P was, 1, 1, negative 1, and you're dotting that with R, 4, minus 3, and 0. Now the dot product just simply means that you multiply the first two numbers, the middle two numbers, and the last two numbers together, and then add up your three answers. So times the first two numbers, add the middle two numbers, add the last two numbers, and you should get a nice simple number there. When it comes to part C, then these little vertical lines mean the magnitude. So it's just like doing a big Pythagoras question. So the x number squared plus the y number squared plus the z number squared. And you know what they are because the first one is the x number, the middle one's the y number, and the last one's the z number. Question 3. Find the value of k so that the tangent is parallel to that red line I've drawn there. Now what do you know about that red line? First of all, you know that it's horizontal because it's parallel to the x-axis, and therefore you know that its gradient is equal to 0. Okay, we're told we've got to try and find at this point here where the x number is -2. So how do you find the gradient from a curve? Well, you take the curve and you differentiate it. So differentiate this curve here. We know that the gradient is 0, so put your answer equal to 0, because you know that the gradient's got to be 0. And you know when that happens. You know it happens when x is -2. So you put -2 into the formula. Okay, so differentiate the top formula, put it equal to 0, stick the -2 in, work it all out, and you should get a nice wee simple answer k equals something. Question 4. Here is the formula for a circle. We know that the centre of that circle is negative g, negative f, and we know that its radius is g squared plus f squared minus c. The question asks to find any restrictions on g to make that a circle. Now, the only thing that can be a problem with a circle is the radius. If a circle doesn't have a radius, it's obviously not a circle. So we therefore need to know that the square root of g squared plus f squared minus c must equal something bigger than 0. If it's not bigger than 0, then it can't be a radius. Okay, now the only way this thing here can be bigger than 0, g squared plus f squared minus c, is if the bit inside the square root is bigger than 0, because you can't square root a negative. So we're going to work with this little formula here. G squared plus f squared, take away c is bigger than 0. Now if I look back at our equation, there's your g number there, which is g. There's your f number there, f, and your c there. Okay, so the equation which you were given, right, which I'm trying to remember, it's x squared plus y squared plus 2gx minus 4y minus 12 equals 0. So from that, half that number is your g, so half of 2g is g. Half that number, change its sign for f. So g is equal to g, f is equal to 2, and c is the number at the end. So you just need to plug each of these numbers into that formula and basically see what happens. Question 5. So the first one you have to work out is the median. So the median is where you find the midpoint. Then you find the gradient. And then you use the y minus b equals mx minus a formula. Okay, so median, midpoint first of all, then work out the gradient, then do the y minus b. For the start of the question, this time you have to find the altitude, and the formula for the altitude is find the gradient at the opposite side. So in this case, here's the altitude, I've drawn it for you this time. You've got to find the gradient of us. Once you've found the gradient of us, then find the perpendicular gradient, and then use that gradient and the point t in y minus b equals mx minus a. Question 6. Show that these 3 points are collinear. So work out what a to b is, work out what b to c is, and you should find that there's some connection between these two vectors that you get. Remember your little sentence that goes in here about parallel and points in common. And then lastly, question 7. F of x minus 1, well, that means you move your graph to the right 1 unit. And the second one, the minus f of x means upside down. And then the negative 2 on the outside then means move it down 2 units. Okay, so first one, move it right 1 unit. Second one, separate diagram, turn it upside down and move it down 2 units. Remember and show the various points on your graph, write the coordinates down. Okay, hope that's fine. As I say, I didn't bring my sheet home, so I hope I've remembered all the questions correctly.